So now that we've had some experience with HVM-based hosts, let's have a look at provisioning a PV host or paravirtualized host. Now again, HVM hosts or guests, or HVM guests that is within our Xen hosts, are much cleaner in that the systems are self-contained, full environments provided, meaning BIOS, grub, etc. So as a consequence, it's much cleaner. You're not worried about dependencies such as the ties to the host system's kernel or initial RAM disk or any other component for that matter. Now traditionally, to provision PV guests within our Xen hosts, we'd normally take a snapshot of key directories from the file system and populate them into some sort of storage container such as an image file or a partition, and then reference the kernel and initial RAM disk used by the host within the guests. That's still done largely, by and large, but there's a much more economical way of implementing the same thing, and that's using XenTools. So XenTools, which is implemented as a package, Xen-tools, simplifies the aforementioned. So simplifies via automation, of course, so it's a script, albeit a large one, series of scripts, the provisioning of PV DOM-Us or paravirtualized guests by writing in information, so information that's unique. Let's just note, let's say by populating unique data. So examples, of course, include the host name, IP, gateway, net mask, perhaps the size of storage, swap, etc., number of CPUs, the file system to use, etc. And by doing all of this, it reduces the number of errors that are typically encountered during this process, let's say during PV provisioning, which is normally a manual affair, which works and can still be done. And XenTools provides myriad options for storage, networking, and other settings that pertain to the guests. So you can, for example, specify where the guest should be stored, whether on an image file, multiple image files, on a logical volume, NFS, which network interfaces, a bridge, different bridge, connect to a different interface. All that can be specified via XenTools. So that sets up a few tasks for us, including but not limited to the installation of XenTools. So let's install XenTools. Again, we're just bypassing altogether doing this manually. And you'll see once the configuration file is generated how similar it is to the HVM. Let's just note that it auto-generates the requisite configuration for PV guests. And it also creates a directory structure in which to contain the guests automatically for you, automatically as a consequence of running the script. So let's get an aptitude going, where we'll install XenTools. And let's copy this in and try it out on our remote system. Let's see if the connection back here is available. Indeed it is. And let's get that going. That should pull it in momentarily. So it'll install a number of prerequisites, as typically the case. We should be up momentarily. Number of Perl modules. And then once that's in place, let's go ahead and try to execute Xen. Notice the various items. Now, of importance to us is the Xen create image. That's the script that does the heavy lifting for us. Now, there are some prerequisites. For example, XenTools makes extensive usage of loopback capabilities, which are usually limited on the standard Linux kernel. So let's just note that as a consequence of this, we'll be using Xen create image, with various options. This is the primary tool. Let's say primary provisioning tool. But let's also note that there are prerequisites that are important. So it's important that we load loopback support for more than the default 8 loopback devices. So load loopback modular support for greater than, let's say, 8 loopback devices. For 1 or 2 PV guests, 8 loopback devices should suffice. However, as you expand them, there will be problems. Now, let's take a quick look at the loopback structure that's in place. If we take a look at dev loop, for example, and tab it out, you'll see the devices loops 0 through 7. So for 8 devices. The reason why these are important is because XenTools will store within an image file the appropriate file systems that pertain to swap and the main file system driving an operating system or a virtualized operating system. The same could be done for an HVM host as well. You could store the entire file system within an image file as opposed to an LVM space, or within an image file and a swap image file, or FS file system image file and a swap image file. Let's just note that loopback support is required to mount the following items. 1, the primary FS volume that contains the operating system or the PVOS operating system, and 2, the swap volume. And both of these, let's just note, are stored, let's say by convention, in .image files. And these files contain full file systems, whether swap or ext3, 4, or some other type of file system. So that's why we need these loopback devices. Now, to influence the change, let's just note, provide bootable support for greater than 8 loopback devices. There are a variety of ways in which you can affect this, but one is perhaps to pass the option into grub. So if we update the default grub entry on Ubuntu or Debian, so update etc default, a file that we've already looked at or made a change to, with a grub command line Linux default entry that includes max loop greater than 8, let's say up to 255 or 2 to the 8, so that's going to be grub command line Linux default, and we'll set this equal to max loop equal 255. And that'll send us up to the max number of loopback devices that we're willing to support. And then, of course, it's required that you reboot the system and confirm. So reboot and confirm additional loop devices or dev loop devices before proceeding with installation. Again, for 1 PV host, or 1 guest that is, it's usually not a big deal. However, just to avoid future problems, let's take this entry and update it pronto. And again, we do have our nodes running, our guests or DOMs, so let's do an XMList, and they're still running, so we'll have to either pause them or suspend them or do something to ensure they're not corrupted. Perhaps we'll pause them, so let's do an XM pause 25 26 XM list, so that way they'll be fine once we resume, whatever the state happens to be. And as far as pausing, if you do an netstat.ntlp in search of, say, 59.0, the VNC port, they're still there. So if you try to connect with VNC, let's say from your local system to the remote system, so maybe from here or this one, let's say to 25, it's still there, it's just that it doesn't respond. So the listener's still there with the anticipation that at some point soon you'll return to continue computing. So let's see what's happening. We'll navigate or just modify using the path etc default grub, and we'll find that command line Linux default. In this line, let's just include a comment to indicate that we were here, and perhaps we'll cut and paste and make use of the following. So that's the entry, max loop, and that'll ensure that it's set once the system reboots. Let's remove this extra quote. That should be good. So that's grub command line Linux default equals max loop equals 25 should do the trick, and that should be good. So let's save the changes. And at this point, we should be able to reboot this target system. The guests or DOM-Us will remain in the state that they're in and resume rather quickly, unless there's some other problem. And then let's send some packets on a recurring basis, maybe every 2 seconds, to Linux CBT ubu VM1 so that we are alerted when it has resumed processing. So reboot, confirm additional dev loop devices, and then move on. So the third thing for us to do at this stage will be to create PV image. And we'll do so sans, let's say sans pygrub. Pygrub is a Python grub interface which facilitates the booting of kernels that are specific to the distinct paravirtualized guests, which makes it possible to manage distinct initial RAM disks and kernels on a per PV basis or per paravirtualized node or host or guest or DOM-U basis. So XenTools by default will reference the kernel used by the host system. We'll wait for this to come back up, taking just a little bit. We should see some activity momentarily, and still unreachable, but eventually we should get some data coming back. Now, paravirtualized nodes do share by default, let's just note. So PV guests or nodes or DOM-Us share by default and by history the following with DOM0. They include the kernel and the initial RAM disk, init.rd. These are both in boot, of course. Whatever the current version tends to be is what we usually use. But for more flexibility, using pygrub is a helpful method. But if, for example, your system can use, let's say, a shared kernel, then that's also a possibility as well. Let's see what's happening. We're not getting any response just yet. 105, we should be seeing some sort of response. So let's just see what it's doing here. Let's try it again. And now it's coming back. Just took a little bit longer than normal to come back. So every 2 seconds we should get a bounce. So good. So it's back up. Let's SSH back in. XM lists. Both are still not available. That's expected. We can do an XM on pause, let's say. Either or. It is not started, so because of the kill, it's not bringing it back. So let's XM start. That means the state wasn't saved on the pause, which caused an issue. Actually, let's try to, and that happens sometimes, let's try to launch a VNC session yet again from one of these windows here. And we should see it firing up momentarily. So that's that node. Now back to our XenTools. That's coming up nicely, so that'll be up. So on the shutdown, there must have been an issue that caused the two nodes to lose their state. So let's take a look here. XM list. The other one is also not up, so let's bring it up as well. That's why we were not able to unpause them. So, but that happens from time to time. Now, with that said, let's confirm the number of loop devices. If we tab it out, and let's just, this should be more than that. Let's cat etc default grub. And update grub. Let's reboot again. And kick off our ping. Before reboot, let's update grub. We should also note that by introducing domains that are dependent upon the main domain to the equation, it can cause reboots to take a much longer time, because usually when you reboot abruptly, domains have to be saved, their state that is. Let's just note that Xen domain hosting will lengthen reboot times, especially when rebooted abruptly due to attempt to save state of DOM-U or DOM-Use. So that's a common occurrence. And even under normal circumstances when things work, you'll find that it will take a longer time to reset the host or the DOM0 or primary Xen hypervisor because it has to take care of the states of the other dependent nodes or guests. The activity in the back, and we do have activity. Let's reconnect and try to ls dev loop, and that should show all of the possibilities. So now we have ample loop devices. We should be able to create our instance. So Xen create image is a rather straightforward tool with myriad options. So one option to run it would be as follows: Xen create image. You can consult the various options. Maybe turn on verbosity, which is long form here. Set some memory, maybe, and again, these are directives that will be set to the config file, so you don't have to invoke it each time. So gig of memory, maybe set the image file that's to be created to be 8 gigabytes. Maybe the swap should be a standard of 1 gigabyte. Again, these are all values that can be generated from, let's say, a web form. And we'll use the standard deb bootstrap installation method, but there are other methods available. Just consult the documentation. But deb bootstrap will boot the system as it does when installing Debian or Ubuntu. Let's set the default number of CPUs to 2. The default file system to the latest ext, which is ext4. Now we should specify a directory where these instances are to be stored, so we'll set a directory. By the way, when you do Xen create image, we just have these items documented, but if you do a Xen create image, you'll see the various options that are available. Let's do a help. It shows you what's mandatory and it shows you where it'll read, but if you check this, these are mandatory options, so the host name, directory, and they're interchangeable, whether on LVM or in an image file. So we need to have somewhere to store these items. So if it's going to occupy 8 gigs, we should have that available. Currently we have nothing available, so we may need to quickly make a volume that can store this. So if we do a VG display, we should see what's available. So we've got 100 gigabytes in XenVol1. And if we do an LV display, we should see so far we've got 2 volumes associated with that volume group. So UbuVB1, that's 8, or Ubuntu Guest 2 and Ubuntu Guest 1, 8 and 8, 16. So maybe we should set aside maybe 24 gigs for our storage location and mount it somewhere sensible, maybe off of the root of the file system, such as XenVol1. So we have to do an LV create with an appropriate size and a given name of the volume, which is XenVol1, as the vol group that is, and the name that we want this thing to be called. So say for flexibility we call it Xen PV guests on XenVol1, and its size will be, let's say, 8 gigabytes. And that creates it, so that's going to be Xen PV guests, which can now be mounted. So let's make a directory, maybe Xen PV guests, off of the root of the file system and mount. Now it's currently not formatted, we need to make a file system on it, that is, so let's make fs then mount it. So let's go make fs ext4 on Xen PV guests, or on dev XenVol1 Xen PV guests, and then we can mount it. That's going to be this path, and of course etcfs tab needs to be updated accordingly. So let's mount this on Xen PV guests, and let's nano etcfs tab just to be sure that it's there. So this path is going to be mounted here, Xen PV guests, type ext4 defaults, and Let's say we ignore checks for now. So that's available. We should see now the space. Actually, we want it to be bigger. So let's U-mount. We could extend, but let's U-mount. We actually want it to be 24 gigs. U-mount XenPV guests. And LV delete it, because that's going to waste extra space. Or LV remove it, that is. Dev should have the path here. So that's going to be XenPV guests. Let's remove it. Let's find that create command again. And that's going to be this time 24. Maybe we'll give it 32 gigs for some space for 4 nodes. And then recreate the file system, which should be somewhere. That'll take just a little bit longer, and then mount it to have the 32 gigs as opposed to 8 gigs available. So let's mount it. And cat etcfs tab dfh. That's more like a 32 gigs. So now we can create in the space XenPV guest. So back to our creation. So it's going to create a hierarchy here. So directory is going to be equal to XenPV guests. And in this directory, it'll create the appropriate hierarchy. We can have it prompt for password. Again, if you check Xen create image, you'll see all of these options. So Xen create image and help grep password, for example. So the password option asks for root password during setup. So it'll prompt us for that. If we do a PASWD, we can set the IP. Let's say we make it 192.168.75. The other one's 106, so we've got 105, 155, 156. Let's make this 157 and set a gateway of the same for all of the nodes. Again, it's going to be using the bridge by default. And 24-bit mask and a host name that should be an FQDN, so equals FQDN, whatever that's going to be. So say it's going to be LCBT Ubu PV1. And the architecture, it's either going to be i386 or AMD64. So we'll go with AMD64 because that is the architecture of the primary system. And then we can decide to have it keep the files in the event that it fails. That's another option, so that we don't lose the file, so we can evaluate if there are problems. And there's also a force option, which overwrites existing images in the event that we have to do it multiple times. So those are optional values that you should consider. So force as well as keep in the event that there are failures. Now, the Xen tool, Xen create image, tends to generate errors because of the multiple options, so things are likely to be missing, so expect errors until you get it down to a proper setup for your environment. So with that said, let's Control-Shift-V to paste that in, and now it's going to walk through the steps that we would normally do to create an image. Now let's see what it's doing here. An error that it's trying to configure precise, but there's no link. So this directory doesn't exist by default for the current release, precise.d, although we could reference stable, that would work. Stable is the current version as the type, so precise is the default type. Precise.d is the derived type from this particular version of Ubuntu. So to create that link, we need to paste it into the appropriate directory. So if we take a look at user lib Xen tools, we can just point it to one of the existing directories. So stable exists, and let's see, that's stable.d. Precise.d is the current version as well, which should just point to Debian.d. So if we ln user lib Xen tools, these are just some of the bugs that pop up, and we want to link to Debian as user lib Xen tools. And this is going to be precise pangolin, but just precise.d, the prefix is sufficient. That'll link it. Actually, we don't need the / there. Let's take a look again. LSL, Xen tools, we should see precise. So let's try this again. Now, it knows that the files exist, the partition exists, so it's force. This is why we said we use this option, so it just overwrites it all together. And try it again. Now you can see that it's copying the files from the host, that's the primary system, into the image. It's executing deb bootstrap with the appropriate architecture, and you can see these references. It's making use of the loop values. Let's try from another shell to see if we can see some activity behind the scenes. So maybe if we SSH here, have a DFH, so you can see 2 loop devices are currently in use, and they quickly fill up. So that's why you need as many at least double the number of guests you're likely to have. So basically at this stage, eventually the distribution will be ready to be fired up, and then you can attach a console to it using XM console, for example. So you need not have a GUI connection. So for example, XM with no options, one of them is console. Let's grab console. So you can then use XM console to attach to it, and the config file will be generated for you. And additionally, while that runs, the Xen PV guests directory is populated accordingly with a top-level container of domains within which we find the following. And these are the two key files. One's a disk file containing the file system ext4, and the other is an image file containing swap 8 gigs in white and 1 gig respectively. And if we do a file star against them, you'll see that one's ext4 and the other is swap, and the script continues to run behind the scenes. As you can see, it's taking care of the Linux modules, and so far so good. Now again, this particular, and errors pop up with XenTools, which is one of the reasons why I prefer not to use it and prefer to use the HVM route. It's just, HVM is just simply cleaner. There's a log you can follow to see this correspondence, so it's there. You can have a look at it, everything that was dumped to the screen, and it's pretty much ready to be fired up. In terms of scripts, the configuration script, if you navigate to etc xen lsltr, you'll see Linux CBT ubu pv1. If you have a look at this file, you'll see that it's structured similar to what we've done already, but notice it references a kernel of the current kernel in use on the host system. vCPU's memory, these are familiar. The root drive, well, it presents a pseudo drive XVDA2 as its default, which is read-only for the root file system. The disks that are in use are disk.image and swap.image, XVDA2 and 1 respectively for the root file system, and swap. Hostname that makes this node unique, IP, MAC information, and what happens to the system. So in terms of whether or not it's registered, if you XM list, notice it's not there, so you can of course do an XM create to start this instance and the name of the file, and that'll cause it to start. And then you could use the C option to try to connect to the console, and it'll dump the contents of this node into the current window. And sometimes again it'll throw image errors that is related to the image and so on, but it should show the dump that's normally on the console in this screen. Now let's take a look from another window. Let's say this one here, clear screen XM list, as to whether or not it's picked it up, and it hasn't. So VBD could not be connected. Device. Let's do an XM new on this item. It's actually not tab completing for us, so let's LSL XM new, and that's going to be this file. Let's see if it takes it. XM list, so it should show up now on the list, so we should be able to fire this up by XM starting it. And that's going to be Linux CBT ubu VM or ubu pv1, and this will attempt to start the node. Let's see what it's doing. So it's the same error. File domains is loopback mounted through dev loop 1. It's actually mounted, so let's umount it. That's the problem. Let's umount dev loop 1. And if we try the console option that we did earlier, it should work. But the new followed by a start should take care of what create does for us. So this will start it up. XM list, and this node will be available momentarily. To connect to it, just use XM console, say 6, and it doesn't show. Let's see if we can do an XM start with the C option. That's going to be on the name because it's already terminated since we've looked at the listing. So PV1 with the C option. This will allow us to connect, and if there are any errors generated, it'll show. So this is paravirtualized. It comes up quickly, but is likely to be buggy, likely to throw up errors. And if it comes up with the login prompt, then you can connect to it, or if there are any errors, you'll need to debug. We'll save for another episode. So this is going through ext mounted file system with ordered data mode, And let's see what's throwing some errors here. Local ext4. Let's do an XM list, see what's going on. So it actually terminated. So there's a problem with the ext4 that needs to be checked. So this is something we can look at another point. But the point is, to instantiate a PV host, you'll use X or Xen create image with various options and then debug from there. But our preference is to use HVM. It's simply more stable, and as a consequence, more amenable for production systems. Although certainly para-virtualized nodes are in widespread use after considerable testing, of course, for your environment.